Hello everybody, I'm Erika Heidi. I work as Developer Experience Engineer at Chainguard, and today I'm going to show you how you can build a Minecraft Java server using Chainguard Images. So let me start with a little bit of me. I have a background in DevOps and systems administration, but also software development. But I'm an experimentalist at heart, so I really like to experiment with things. And I started playing Minecraft less than a year ago with my daughter. And I'm still a noob, but I'm very interested in the technical side of it, how to set up servers, how to create resource packs and things like that. Which led me to this presentation. My favorite thing to do in Minecraft is to jump on a boat and go exploring the world. Alright, so in this presentation, I will start talking a little bit about Minecraft servers in general and also the Log4Shell vulnerability. And then we're going to see a basic containerized setup. And then I will talk about how to improve the security of your Minecraft server. A few tips. All right, so let's jump right in. Minecraft is an open world game where folks can build, explore, and fight monsters in a pixelated world. This is something very interesting. They have the guidelines in their design. They have a design book with some guidelines, and one thing that is important is to keep the funny, silly look, even though there are monsters and there are scary things in Minecraft, but there is no gore, no blood, and also it is made to be a little silly, a little funny. This is the best-selling game of all times. So there is an active user base of average 170 million monthly players as of 2024. It has over 300,000 copies sold. It's a game that is going on for a long time and still being active developed with many new things coming every now and then. New biomes, new animals, new mobs, new monsters. And one important thing to know about Minecraft is that there are two versions of it. There is Java version and Bedrock version. So Bedrock runs on Windows and on consoles, while Java runs on PCs, Windows, Linux, and Mac OS too. These versions are not compatible with each other, so you cannot, for instance, join a Java world from a console because consoles run Bedrock. So in this presentation, we'll be focusing on the Java version, which is, it has a few differences. A lot of people prefer the Java version. There's less bugs apparently. And I played for a little bit the Java version and I also liked it a lot. I think it's nice that it's easier to customize with resource packs. You can create easily texture packs and customize the appearance of things. And also you can test new stuff very easily. Like new versions, when they add new things to the game, then you can be one of the first people to try it out very easily. So one thing is that to play with friends, you need a server, right? So there are public servers out there, and there's different alternatives, but in general, you need a server. And public Minecraft servers are often a target for exploitation. And there is like a few different reasons for that. One is that not all people who to set up Minecraft servers are experienced systems administrators. So what happens is people sometimes forget to update and patch their servers, so it keeps going on outdated versions, so a lot of things can happen. And since it's a public server, so it's open to the public, there's not much you can do. People might join and also just create havoc in your world, destroy things, and such. But there are other risks, like who remembers Log4Shell? So Log4Shell was a vulnerability discovered in December 2021, although it has been privately reported long before that. But that was when it actually went public, and Minecraft servers were among the first targets. So in a way, the other Minecraft helped bring visibility to this severe vulnerability with a CVEs rating of 10, which is the highest rating because it allowed remote code execution on affected devices. And in Minecraft, this was really crazy because anyone could join a Java server and write some strings on the chat and be able to execute commands on the players' computers. So this was really bad, of course. They can execute arbitrary code on the players' computers through messages in the chat. Mojang, the company behind Minecraft, released an official statement urging admins to patch their servers. So really, although they were the first targets, like they also went about fixing it very quickly. And incredibly enough, today there are still vulnerable applications, servers, we don't know, but there are still downloads of vulnerable versions of Log4j, more than 10%. And this is like nearly 3 years after the fix were made available. So there are still people downloading affected versions as of today. This can be like applications that don't have updated their dependencies in a long time, you know. So yes, it's probably still running somewhere out there. I asked on Reddit some personal stories about this period, which was like, and it was close to Christmas, like holiday, so it was really crazy. December 2021. Some people brought stories. Really, you didn't have an alternative. You either update ASAP or you just shut down for a while and then clear up things because it was really serious. Nobody wanted to join your server anymore. Like, people were scared, of course, with reason. So you had to update. And the second message, there is a guy telling about, he first had a lengthy story about how it happened for him, how he stayed awake late to fix his server. And it was really interesting because he's a person that is also in IT. So they say that it took over 2 days until the topic really came up in conversations. So Minecraft was at the epicenter of things, you know, and it's really interesting to see how this happens so quickly. And what lessons can we learn from Log4Shell? So there are two important things, two important topics here that we can talk about is awareness and also keeping up with updates. Awareness is knowing which versions of software you run, basically like being able to quickly identify. You don't need to, you're not going to memorize all versions of software you depend on, but you need to have like quick ways to verify versions. And SBOMs are a good asset for that, software bill of materials. If you are using a container image with SBOMs, then you know exactly which versions of software is running in there, for instance. And be mindful of your dependencies because more software equals a larger surface for attack. And you really have to figure out what you need to have as a dependency, and don't bloat your application in your system with things that you don't need, because it's another way that another bug can happen. And the larger is your surface, the more vulnerable you are. And the other thing is really important to keep everything up to date. It's really important to have your application dependencies up to date and your system dependencies up to date. And patching should not be optional. You really need to update and keep things updated. All right, so we talked a little bit about Minecraft servers in general, how they connected with the log4j vulnerability. And you know what? Of course, it happened already in 2021, but nobody knows. Anything can happen at any time. And some things we cannot prevent or prepare. You have to be ready to remediate as soon as they appear, right? But there are, of course, measures you can take to make your containers more secure, your servers, your Minecraft server in this case, or your application environments. And let's talk about containerization. Why containers, right? You are running your Minecraft server on a bare metal server on a VPS, and you never had issues. Maybe you didn't, but other people had. Well, containers are isolated environments that won't add new dependencies to the host system. So this is already a big advantage. As we know, Minecraft runs on top of Java, any version, servers and clients. So you need a Java runtime, and you won't need to install it on your host system. It's a lot harder to update it this way. If anything goes wrong, then your whole host system is compromised. When you containerize an environment, then you don't need to install anything on the host. Everything will be virtualized, and your host will be isolated from the application at that runtime, in this case a Java runtime. It is also harder to exploit containers due to less available resources, especially when we are talking about minimal images like Chainguard Images. Containers also can be destroyed and recreated easily, programmatically, making these environments reproducible, which is another important characteristic of secure systems, resilient systems that can be recreated easily. Disposable environments make updating easier too. When a new version of a dependency comes out, you can just remove your containers and recreate your environment with an updated image. It's also a scalable architecture. You can create 1 or 100 Minecraft worlds. If you have a reproducible environment that you can dispose and recreate, you can create as many as you want. And this is scalable. You can also work with volumes to replicate your nodes and have this setup running on multiple nodes, even if you want to create a huge server. But actually, even if you're running only on your computer, on your personal computer, or on a remote VPS, a bare metal server, if you containerize an environment and you run it through a tool like Docker Compose, you still be in advantage because you have an isolated environment. You can dispose and recreate it, and you can create multiple environments if you want on a single server. So there are many advantages of using a containerized setup. And why Chainguard? Well, the main reason is no CVEs, of course. So not all images will have 0 CVEs all the time, but it's really close to 0 most of the time. And many times it's 0 like this. This was yesterday. Our Java runtime image has no CVEs. At least at that time it didn't. We will run some grep scans in a moment so that we'll be able to really compare some alternative container images for Minecraft servers and our Guardcraft image, right? So how does a setup look like? How does such a setup look like? So we have here a Dockerfile for a basic setup, and it starts with the from line. We are using the Java runtime image, the latest dev variant, because the latest dev variant has APK and has a shell. So it is a bit easier to work with it. And we need to install a couple dependencies, curl and libdev. These are requirements for running the server. So we start setting, specifying the user root, because most Chainguard images run as a non-root user, which is another security measure. So we have to change to root here, so we are able to install packages. Then we run apk update and install curl libdev. Then we add a system user named Minecraft and set up the work dir. Then we download the server file. It's a jar file, and this URL is shortened to fit. It's a much longer URL. I cut a part of it, but you'll see in the actual Dockerfile in a moment. And then we run Java to unpack the jar file. Then we set the eula.txt file to say that we accept the terms. So it's just really a text file with false, and then you change it to true. And then we set the permissions for the workdir to the Minecraft user, change to the Minecraft user, and then we run, finally, we set the entry points to the jar file. So this will run the server with default settings. Okay, so it will be a survival mode road with a random seed, which means that we will land, when we start the game, it's going to be a random place for all players. It's the same, every world has the same spawn points, and this is set at when we build the image in this case, or can be set also at runtime, but it's really an option in a configuration file that we'll see later. Okay, so this will use default settings. And then we have the Docker compose file just to facilitate sharing the port and etc. We define a service called Minecraft Java, and we give the image a name, and we're gonna build the image in the current folder. And then we set the port and restart unless stopped. I'm gonna switch to the terminal. Okay, so here I have the same Docker file that I show in the slides. Okay. And the same Docker compose file. So I'm gonna build the image with Docker compose build. This is cached because I have built this before. But yeah, you can see all the steps here, run add user, and the downloads here. Where's the download? Here, the download is here. So this URL, as you can see, is a long URL. Okay, we'll talk about this later. But yeah, so the image is built. We can now run Docker compose. And then we'll see all the outputs coming from the server initialization. So this is because by default worlds are online, which means that it's not a bad thing, really. This is a security measure. It means that users will have to authenticate with Mojang before joining this world. They cannot have like random anonymous users joining, which is a good security measure. And this is by default like that. You can turn your world like offline, but then you will allow anyone to join without an account. So it's a choice. So here we're using default settings, and then you say here that there is no existing world data, so it's creating a new world, loading recipes, advancements, and the Minecraft server version 121.4, which is the latest stable. Game type survival by default. Then the port is 25565, the same port we are redirecting on the Docker Compose. And preparing rows, preparing start region, spawn area. Okay, the server is online. Now let's see if I am able to join it. Okay, it's now running here. Then you go to multiplayer, and then I actually already have set it before here. So this is localhost. Okay. So we're gonna join now. And then, yes, we are here in a random location. Planes. And I want to show you the output from the terminal, of course. Let's see the terminal now. Okay, so you can see here user authenticator. So it shows the username and the UID of the user and the location, the coordinates where the user spawned. It says that I joined the game. And when I leave, it also will say that I left the game. Let me go back there. Yes. Gonna close it now. Let's see if I can see. Oh no, we're not using the resource pack yet. Okay. Disconnect. And then you see that the user has left the game. Cool, it's already working. But of course, this won't do. We want more options, configuration, and etc. So I will go ahead and this was a totally disposable roads that you can create as you wish. Now I want to talk about securing your Minecraft server or improving your setup, because this was very basic. Oops. And you want to be able to configure your server, you want to be able to set additional options like the game mode, the game difficulty, the spawn point, and many other things, resource specs. So let's talk about additional steps for improved security. Okay. So the first thing you want to do is customize your server with a configuration file. So the configuration file is called server.properties for the Minecraft configuration file, and it's located at the root of the installation folder. So there are mainly two ways to do that. You can copy the file, create a version, a custom version of the file on your working directory in your host machine, your project directory, and then you copy this over to the server. This is the easiest way, but then what happens is that the configuration is applied, in this case is set at build time. So if you want to change anything on your configuration, if you want to change your spawn points, the modes, the port, everything, you will need to rebuild the image. Okay, so maybe it makes sense for you, and that's fine. And another way that it's my preferred way is to create a bash script that will work as Docker entry point for your image. And in this script, you will check for environment variables to configure the server. In this case, what happens is that At build time, we will just copy the script over and set it as entry points. And at runtime, when you run the image, you have to provide some environment variables. These are actually can be optional since there is a default configuration file. And you can only configure what you want. You don't need to set up the whole configuration file and copy. And then you'll be able to just change some variables in the Docker Compose file and then bring your environment up again with the new settings. So this is what I implemented in the Guardcraft demo, which is the second demo that we're gonna see. So this is one thing. You have to be able to configure the server, so you might need a bash script for that. The other thing that is very important is to keep up to date with the latest Minecraft software. As I talked before, the URL, that long URL to download the server jar file is a unique URL, and which is good in some ways. It seems to be an immutable URL. However, you need to update, right, eventually. So it's also preferred that you create a download script to programmatically fetch the correct jar server file. This is also something that I have implemented in the Guardcraft demo. I found some APIs from Mojang and Stack Overflow, looking over Stack Exchange, I don't know. I found some tips on how to fetch these files, and there is actually a public API. This is the same that the client uses to automatically update. So you'll be basically using the same things, which is great. So the download script is important, and then other things now for security, really security measures, are like keeping your base image up to date, the JRE image. So preferred way to do that is using a digest, which keeps the image to the same version instead of using latest dev, which is like pinning to a version that is an unknown version in the future. When there is updates, you will be updated when you rebuild, but at the same time, you want to specify a build of that image so that your build is also reproducible. Your Dockerfile will be reproducible because you're using the same exact base image. It's a specific build, not a tag that will change, you know? So you can set the Dockerfile to use a digest, and then use Digestabot, which is a GitHub action that will create a pull request whenever a new image is out. So it updates your digest. This is a good measure for, at the same time, keeping your build reproducible and also being able to update it easily through a pull request. You still have to build the image, rebuild the image, and this is depends on your deployment methods, but you need to keep the image being built, eventually every night maybe, or with a certain cadence, so it gets the latest updates. Other important thing specific to Minecraft is change the default port. Is a simple measure that will already give you a little bit of more obscurity, so it's not so easy to find your server because people will scan for servers. Use an access list is another method. It's another security measure you can take. So you can create an access list for your server. In that way, only usernames that are in the list are allowed to join your world, your server. Usually, it's a good measure when you have like friends, specific people that are joining, and you want to set up the access. It's a good measure too. And keep server online. This is by default. This happens by default. I talked about this before. about authenticating to Mojang, so only authenticated users can join your world, your server. This is a good security measure as well. Can be turned off, but by default it's already like that, so don't turn it off. Okay, so now we're going to demo 2, and now I will really show the Guardcraft repository and show a few things there, and then we're gonna git clone it and run the demo, right? So this is the Guardcraft server demo repository, where you can find all the files, and some things are different here. As I mentioned, I created 2 bash scripts. So let's have a quick look on those. The build-config script, it reads from environment variables that have the MC prefix, and then it will use sed to change these variables in the configuration file. So you can have a look at the script in the repo. And the other file, the other bash script, is the server install. So I'm carrying the API, the Mojang API for the versions manifest, and then I find that version and do a new request to get the download artifacts from that. And then I check the SHA to see if it matches. So this is a good download. And then only if it works, if the check is successful, then I use Java to unpack the file and then use sed to set the EULA.txt file. So these 2 final lines I can remove from the Dockerfile, because the installation really happens in these scripts. So here is the updated Dockerfile that is being used here on the demo. As you can see, I'm using a digest here. So this is already being updated a couple of days ago with the latest JRE build. Saying the same thing, the beginning, but the difference is that I have a copy instruction to copy the bash scripts to the image, to the work dir, and then I set permissions and run the server install, and then the entry point also changed. So what I'm doing is I'm using a Docker entry point script that works as a kind of proxy. So it will run the build config to get the environment variables, but it will then, after everything is run for the environment variables, then it will execute the actual entry point, that is the Java commands, to run the server. So these are the main differences from the basic setup to these. And the other thing is the GitHub action for Digestabot, the image digest update. So this is a GitHub action that you can set up. You can search for Digestabot on GitHub Actions, and then you find this is the action that creates the pull request. You only need to remember to go to your repository settings to allow GitHub to create pull requests, the GitHub bot. So there is an option there for that you have to allow. Okay, so let's go to the terminal to actually see the demo. I'm gonna copy this. So I'm gonna clone it here in a separate folder. So we have our Docker file, our Docker compose file. Let me show you the Docker compose file. This is something that we'll need to edit. So there are a few changes here. We have now the environment variables to set up the configuration. So I'm setting here game modes, difficulty, multi-D, multi-D, level name, calling Guardcraft. I'm setting a level seed. And this is something that I didn't mention, but I created a custom resource spec. And this is how you enable it with a resource spec configuration. And you can also do this and specify the SHA-1 of the download file, the resource spec downloads. So this makes it more secure, of course, because you cannot just change this zip file to have something random on the release. It needs to match the SHA-1. And then I create an ID, a unique ID, because it was complaining in the output. So I set up a unique ID, and I also telling that it's not required to download this to join the server. So if users don't want to use it, it's fine. Okay, so this is our Docker Compose file to configure the server with our custom options. I'm gonna close it here. So another thing that I would like to mention is about the ports. So to change the default port, this is important if you are going to run an online server, like a public server. This is important. There is an option also that you have to set with the environment variables, or another way, in the server.properties file. You change the port there, and then you remember to change it here if you're running it with Docker Compose, to change the redirect here. Okay, so I'm gonna leave the default port. So you start by building the image, Docker Compose build. Then we will make sure that we are downloading the latest server version that will match the latest snapshot on the client, which is now 121.5 pre-release 3, I think. Okay, let's see. We see some output from the settings. Yes, 121.5 pre-release 3. Okay. It's a new world, no existing data, creating new roads, preparing spawn points. Okay, it seems to be up now. And one thing to keep in mind is that this is an ephemeral environment, an ephemeral road. And if you want to keep your world data, you need to use a volume. But it's fine also. It's not a big deal. You can create a volume and easily keep your data. So when you destroy your containers and recreate them, you have your world there. In this case, I don't need to keep the data, so I didn't set any volumes. Okay, so now just wanted to show here in the launcher, the latest snapshot matches the server. So let's run this and then change the window when it comes up. It's loading. Okay, now fix this. Okay. Okay, let's see now. Okay, so you can see, for instance, I have another server here that is another version, so it already shows you that it's incompatible. This is the one that I'm running here, localhost. So let's connect. right? It looks similar. What is that? Looks similar to the other one, but it's actually a different place. It's hi horse. It's there is some villages here that I want to. Let's see if the resource pack was actually applied. Where is Linky? Oh, I see. I see him. I see him. Hi, Linky. So, okay. A beautiful rose. Yes, we're arriving. Hi, Mr. Villager. Everything works as expected. That's it. Okay, now there's one important thing left to do, which is scan the images. All right. So let me close this, stop the server. Let me pull. So when I started building this image, I was looking at Docker Hub, and one of the most popular images I found that it still has updates was this one, ITZG Minecraft server. So let me make sure I have the most recent version of it, so we can scan with the latest version. I'm gonna pull it, and then I'll pull and then our image is already built here locally, so I will scan that one. Okay, let's grab this. Yes. So for those of you who don't know, Gripe is a CVE scanner. It has a large database that it consults and is always updated, and it checks the contents of a container image for vulnerabilities, known vulnerabilities, CVEs. And then it also gives, it identifies from the database the level, if it's like a critical, high, medium, low. As you can see, this image has quite a lot of files and executables. Let's see what will come up. 21, 22. 100, 120. Okay, so we have here quite a lot of vulnerabilities in this image. The summary says 139 CVEs and 3 critical, 4 high, 68 medium, and then it goes on. Of course, critical and high are more dangerous, let's say, but stuff can be also combined sometimes, so it's bad to have that many CVs, of course, even if you didn't have any higher criticals, but in this case there are plenty. And now let's scan our image. So the name of the image, just to confirm, this new one that we built is Guardcraft Java. Let's see. It's also important to notice that some vulnerabilities are introduced by the application in the terms of application dependencies. For Java jar files, there are dependencies of the Minecraft server. So a few vulnerabilities may appear in the jar archive. And these are not from the image, but from the application. Okay, so there is currently two fixed, two high, two vulnerabilities. Although it only shows one here, so I'm not quite sure. Where is the other one? Yes, JSON Smart, which is in the Java archive, which means it's not part of our Java runtime image, the base image, but it's introduced by the Minecraft server. These latest updates, so yesterday I was scanning and there were a few others, but these latest updates of the server, the jar itself, already came with updates too, like with patches. So now we only have this JSON Smart one. If you Google this, you'll find some more details about it. But yeah, it's not in the Java image. You can also scan the Java image just to confirm. Let me update it. Let me authenticate. Okay, so if we grab yes, there are no vulnerabilities found. 0 CVEs and 1 CVE for the Guardcraft image because of a dependency, a jar dependency of the Minecraft server. So pretty good. So that was all I had to present today. We will be doing a live presentation soon. So keep an eye on socials for that. We will share soon the dates of the new learning labs that we will be presenting with this content live. And then we will also be doing a live gaming session after the event. See you next time.